What's up, everybody? Coach Sharf back here with the videos for the 200-page packet. We are doing this video for page 16, which again will finish the work for the week of April 27th through May 1st. So jumping right back in, we're at problem 84. What's an equation of the circle shown in the graph below? So now we have the graph of the circle. We've seen one or two of these like this, but I think it already had the center plotted for us at a minimum, which it doesn't here, okay? So, again, to get an equation out of this, again, if we look at the equation of the circle, we need the radius on the right-hand side, and then h and k are the coordinates of the center of the circle, but I also need the opposite sign from what it actually is, okay? If I look at this circle, okay, I don't even know if there's actually any in quadrant 1. It looks like it cuts through the origin. There's a little bit in quadrant 2, a little bit in quadrant 4, but it's mostly in quadrant 3, right? Including probably where the center's going to be. Okay, if I look at all my answer choices, all my x coordinates are 3, all my y coordinates are 4. And then even if you look, they're the same signs. 2 negative here, 2 positive, 2 negative, 2 positive. So let's think about that quadrant 3. Again, if we know our quadrants, everything in here is negative, right? Negative x, negative y. So my center, again, I'm just going to kind of throw a crapshoot in here, although I think I did place that. I might be a little off on that. If I place my center in there, no, I think I did that right. I did place that right. Okay. If I just put my center in there, again, this would be 2 negatives. So a negative x and negative y. So when I change the signs to put them in here, my equation, they need to be positive, all right? So I'm actually going to have positive 3, positive 4, because if you actually look where I put the point, I got negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, negative 4. So I did wind up putting it right in the center, okay? So now, again, I need radius squared, right? Again, you can count it out, up, down, left, right if you want to. 1, 2, 3, 4, 5 spaces gets me edge of the circle. My radius is 5. But I want it squared, not times 2. All right? So 5 squared is 25. I'm not doing 5 times 2 to get 10. So it's going to be answer choice 2. All right? X plus 3, because, again, I want the opposite sign of the negative 3. Y plus 4, because I want the opposite sign of the negative 4. And my radius squared. All right. Okay, problem 85. Let me erase what's on my screen. What statement is true about every parallelogram? All 4 sides are congruent. The interior angles are all congruent. 2 pairs of opposite sides are congruent. The diagonals are perpendicular to each other. Well, again, if you remember the rules, if we run down them, the opposite sides are parallel and congruent to each other. Okay, that looks like number 3. Opposite angles are congruent. It says interior angles are all congruent, but that's all 4 angles inside of the shape, right? So that would be, if I drew it, all right, it's saying all 4 of these angles are congruent to each other, which we know is not true, okay? If we had a rectangle or a square, again, I'll draw a rectangle, and I'll tell y'all why in a second, okay? This is still a parallelogram, okay? Again, the main idea about it is the 2 pairs of opposite sides are congruent and parallel, so those are the same in their parallel, these are the same in their parallel. Opposite angles are congruent, 90, 90, 90, 90. Consecutive angles are supplementary, those 90, 90 add up to 180, same all the way around. Diagonals do bisect each other, trust me, okay? So on this one, again, these would all be right angles. All the interior angles would be congruent. Again, a rectangle is technically a parallelogram. It just has additional features that make it a rectangle. So all the interior angles are congruent there, but would not be on that one, okay? So, again, that might be true sometimes, but not all the time. Okay, all 4 sides are congruent. Number 1. Again, we know that's not true. If we had a rhombus, that would be true. And again, a rhombus is still a parallelogram, but has additional things that make it a rhombus. That's true for a square, but again, it has additional things that make it a square. But again, like with the parallelogram that I showed, all 4 of the sides are not congruent. The diagonals are perpendicular to each other. We talked about that in a recent video. Again, y'all allow me to draw it real quick. Let me put this down real quick. Try to draw it. All right, so that looks a little closer than what I was trying to go for, but if you look at it, let me draw a really elongated one actually, to make it more obvious. Okay, all right, there's a parallelogram. I know it probably doesn't look perfect, but whatever. All right, but again, if we look at it, these angles are obviously, and I'm looking at these to be right angles because again, that's what perpendicular is. I forgot to include that. So again, if the diagonals were perpendicular, they would form 90-degree angles, which those clearly do not, all right? So it has to be answer choice 3. The two pairs of opposite sides are congruent. All right, 86, another circle equation. We're getting a lot of those. I think y'all should have the hang of it at this point, even though we didn't get to teach it. Again, there's some other stuff besides what we've seen on here, but yeah, depending on who you have for Algebra 2 next year, they might try to get that in since we didn't this year. You might see it again eventually in pre-calculus. But let's just look at what we've been doing, all right? Which equation represents circle O with center 2, -8, and radius 9? Again, if we come back to our formula, so we're going to use the 2, -8, but we want to take the opposite sign. So -2 and +8, and we want the radius squared. So we don't want 9, we want 81, all right? So we want -2, +8, 9 squared, which is 81, which would be answer choice 4. All right. All right, problem 87. All right, we have a proof. Again, we didn't do a lot of these. I've seen a couple throughout all these different problems, all right? So let's kind of work through this one. Given ABCD is a parallelogram, a student wrote his proof to show that a pair of its opposite angles are congruent. Again, that's a rule we're given, but even with it being a rule that we're given, we still have to prove it, okay? All right, ABCD is a parallelogram given. Line segment side BC, however you want to say it, is congruent to side AD. And same with AB and DC, all right? Opposite sides of parallelogram are congruent. Again, that's a rule that we're given. AC is congruent to CA. So you can say we're using AC for this triangle. We're using it as CA for this triangle, but we're still talking about that line going through. It's congruent to itself because of the reflexive property, reflexive postulate, same thing. All right, so again, if we kind of do this on one of the last videos, all right? So if we're saying AB is congruent to CD, BC is congruent to AD, and AD is congruent to itself, those two triangles are congruent to each other by side, side, side. And we've mentioned this previously. At any point in a proof, it's already telling you that it is proven it's a triangle through anything else, or through any congruency. Anything else after that can be justified by corresponding parts of congruent triangles are congruent. Again, we shorthand that to be, I don't know if y'all, let me try to get the blue marker, see if it'll show up a little better than the green one. We could shorthand that to, I don't even know why I'm writing here, I could write on my whiteboard, but anyway, CPCTC. Corresponding parts of congruent triangles are congruent. So if you've already proven two triangles are congruent, okay, that's all you need. That's the only justification you need. I've already proven they're congruent, so I could say any other corresponding parts are congruent because I already know the triangles are congruent, okay? So that is going to be answer choice 3, all right? Triangle PQR has angles in the ratio 2, 3, 5. What type of triangle is PQR? So this is pretty similar to the problem we did on the last video, okay? And you can actually say that's 10 total parts, 2 plus 3 plus 5. 180 divided by 10 is 18. So this would be 2 18s, 3 18s, and 5 18s, right? But you don't even necessarily need to do that because it's talking about the angles, okay? None of them are equal, right? There's 2 parts, 3 parts, 5 parts. So 3 different size angles, okay? If you really want to do the math just to see it, again, 180 divided by 10 total parts is 18. I have the ratio of 2 to 3 to 5, so this would be 36 degrees. I don't know why I put the colon. 36 degrees, 54 degrees, 90 degrees, okay? Well, actually, we do need it for a reason, because I was just looking at, I was thinking equilateral isosceles scaling, but that's not what the answer choices actually are. I didn't actually read the answer choices. Getting ahead of myself. All right, what type of triangle is PQR? So I actually do need to do this, okay? So I got 36, 54, and 90, okay? So again, if I look at all of them, cute, it means all 3 angles are less than 90 degrees. Well, we have a 90-degree angle, right? I know you already see the right answer, but I'm just running through them anyway. Isosceles, 2 angles are the same. Clearly we don't have. Obtuse, 1 angle is greater than 90, which is what we do not have. And then we're down to the answer choice 4, a right triangle. And again, I already showed that one of the angles is 90 degrees, so it is answer choice 4, right triangle. All right, so that does it, I believe. Let me make sure. All right, yeah, that does it for page 16. So we're caught up through the week of April 22nd to May 1st. And again, like I said at the end of the last video, probably by the time y'all see this, I'll have already sent out the message on Monday morning. I'm doing these on Sunday night. That this week, the 4th through the 8th? 4th through the 8th is going to be our last week of new work, okay? Told y'all we're going to work all the way up to the 15th, but we made a decision to end the new work this week to kind of give y'all a chance to catch up, because I mentioned it before. I think they did say the last day to turn in work was the 15th. Again, you know, depending on the teacher, they might be lenient and take it that what was supposed to be out last week of school. But we do have to have grades in by a certain point, so it kind of depends teacher to teacher. But I'm telling y'all, you know, at least in Algebra 1 geometry, and this is all the teachers, last week's the last week of work, and I need everything done by May 15th, okay? You know, again, been pretty lax with this, been posting all these videos, y'all copy the work, so, you know, there's no reason for y'all to still kind of be dragging after May 15th, especially if, you know, giving y'all no work, what's supposed to be out last week, and a chance to catch up. So, yeah, 1 more week of new work. Hopefully I'll get to meet with y'all at some point this week. And until then, this is Coach Scharf signing off.